Hey class, I wanted to take a minute to record a problem-solving video for your homework 2 assignment or chapter 2 assignment or unit 2 assignment or whatever I happen to call it. But I'm going to share my screen and kind of just do it similar to the last one where I worked through some of it and then left some of it for you to do on your own with your whole brain. So hopefully you can see here. These are your questions for this unit assignment for unit 2. And we've been talking about z-scores and converting things to z-scores and converting them back to raw scores or converting them from one raw score to a z-score to a different type of raw score and things like that. So here are some homework questions or some applicable questions to work through that. For a set of observations with a mean of 60 and a standard deviation of 12, find the z-score for each of the following raw scores. So we have 1, 2, 3, 4, 5, 6 raw scores here. And you can go back to the lecture video and look at the PowerPoint and pause it to see the formula or see it explained. But you'll remember that I'm going to draw down here again. Let's see, but I still want to see our question. Okay, so you remember that our formula is the z-score equals x minus mu over sigma. Remember what that means. So x is our score, right? Minus mu, so that's our mean over sigma, which is our standard deviation. So we have the mean. So let's write all of our things out here, right? Our key. So we have mu, we have our mean, and that is 60. So if you always write out your little key, it helps when you're doing the problem, when you're putting in your formulas. And our sigma or standard deviation is 12. And you need to find the z-score for each of these. So you should have 6 answers. So z equals x. Well, what's our first x? 75. So we'll do z equals 75 minus mu. What's that? Oh, that's 60. Divided by sigma. Our standard deviation is 12. So you'll just compute that and you'll get your z-score. So you'll do that for all 6 of those. And then number 2, for a set of observations with a mean of 25 and a standard deviation of 8, find the raw score for each of these. So in the first one, you were finding the z-score for the raw scores. And in this one, you're finding the raw score for the z-score. How do you do that? Well, go back to the lecture and watch. Or watch this. Okay, let me erase these. Okay, let me get my notes moved over it. So we have, let me see, that's okay. We'll leave, well, I'll take that off. So I'm going to put up my key again, right? So my n equals 1, 2, 3, 4, 5, 6. My n equals 6. I'm going to do my mu is 25. My standard deviation, my sigma is 8. And then for this first one, my z-score is 1. So what I'm going to do is, sorry, I'm just making sure I do it in the right order that makes sense for you in the video. Okay, sorry about that. I had an error on my notes and I was confused and I didn't want to share my error with you and confuse everyone else. So let me go back to my screen. Okay. I was right. We don't, and not that we don't care about n, but in this situation, writing n was kind of pointless. So I did write our mu of 25, grabbed from right here, and then the standard deviation of 8, which is right here. So x equals, and the reason we're trying to solve for x is because that's what the raw score is. And so remember, our raw scores are x. So we're trying to find x equals the z times sigma plus mu. So for this first one here, z is 1. So we'll say x equals 1 times, what's sigma? 8 plus mu, well, that's 25, equals, and wherever that is your x score. So just do that for this first one, and then for all 6 of them. And that's question number 2. Sorry about that. Erase, 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 erase. Okay, number 3. A set of observations with a mean of 76 and a standard deviation of 12 is transformed into a standardized distribution with a mean of 100 and a standard deviation of 20. Find the new standardized score for each of the following values from the original set of observations. What? How do we do that? Well, I'm so glad that you asked. Um, so we have our 1, 2, 3, 4 x scores here. And what we're going to do first, you need to transform your original x value to the z-score, and you're going to use your original mu, your original mean, and your original standard deviation transformed into. So this is the new one. So here's our original one, right? So you're going to transform your original x value to the z-score using your original mean and standard deviation. And then once you've done that, you can transform your newly found z-score to the x value using the values of mu and the standard deviation of sigma for the new one. It's a lot of words. What does that look like? Okay. So we'll do it for this first one first. So let me write down here. We have mu of 25, not of 25. Why do I think I have mu of 25? Let me look at my notes. Apparently I have 2 errors on my notes. I don't want to re-record the video. We're like mostly through it. Yeah, let me ignore that for a second. So we know x equals what we just did, right? Our z-score times sigma plus mu. So for this first one, I'm gonna pause the video again. I'm sorry, y'all. I was ready. I was so ready. But now that I'm actually recording, I am seeing a couple of errors and I don't want to confuse you all. So bear with me. Good news, it wasn't an error on my paper. It was the wrong page. I just didn't flip it over to the right side. And I was a little frazzled because, you're watching me right now and I'm going to post this to the World Wide Web on YouTube and look like I don't know what I'm doing. But I just flipped the page over to the wrong side and then I was confusing myself. So come back with me to question number 3. Okay, so we have our first one here. So Ax is 61. So we have a mu of 76 and a standard deviation of 12. And for this one, x is 61. So what we're going to do is we're going to try to find the new standardized score. So we need our z-score. So z equals x minus mu divided by sigma. We're going to do that. So for this one, for the first one for A, it's 61 minus 76 over 12. So when you do your math, we get negative 15 over 12, which equals negative 1.25. So now we have transformed it to a standardized distribution, but we need to find the new standardized score for this value. So what we need to do now is we need to take our x equals our z-score times sigma, not equals, sorry, plus mu. And let's figure what that tells us. So our z is negative 1.25. So negative 1.25 times sigma, which is 20 because our new standard deviation is 20, plus mu, and our new mean is 100 right here. Equals negative 25 plus 100. I want you to show each step so I can follow along. So if you have an error, I can see where you're going wrong, which means our new x is 75. So you can only get your new score, your new standardized score for x equals 61. Now it's x equals 75 with these new ones. So you do these two parts, right? So do that for A, B, C, and D. All right, let me erase it again. And then let's talk about number 4. And I'll turn to the right page. After I erase these hundreds of markings that I made. Okay, a set of observations has a standard deviation of 8 and a score of x equals 44, and this corresponds to a z-score of negative 0.5. What is the mean of the set of observations? Let's see. So we know that x equals z times sigma plus n. So that's our formula. Now what do we do? So for this one, x equals 44. So 44 equals, and we know z, negative 0.5 times sigma eight plus mu. Do we have mu? That's what we're finding, obviously. So how do we find that? Let's solve. So we know if we have 44 on this side, plus this is not that, negative 4 plus mu. So just solve for that. 44 equals negative 4 plus mu. So negative 4 plus what equals 44? 48. So we know that mu is 48. Bam. But I probably didn't want to put that on here because now you know the answer. Mu might be 48. Oh, I never clicked share because you didn't see it. Y'all, this is terrible. You can see it now. You didn't watch any of that. Look, I was drawing. Here, x equals uh x equals z times sigma plus mu. So we know here 44 equals z was negative 0.5 times 8 plus mu because our sigma was 8. So 44 equals negative 4 plus mu. So negative 4 plus mu equals 48 or equals 44. So must be 48. All right. Last question. I have had coffee today. You just can't tell, apparently. Or maybe I've had too much coffee. What am I drinking now? I'm drinking a cranberry ginger drink. It is mediocre at best. All right, number 5, last one. But I'm not going to give you the answer this time, so you have to do something on your own. A set of observations has a mean of 45 and a score of 50, and this corresponds to a z-score of 2. So what's the standard deviation? Well, I'm so glad you asked. So we'll put our little key up here. Mu equals 45. X equals, for this one, 59. And Z is, look, I just go right into my equal sign, 2. So we know that X equals Z times mu plus, or Z times sigma plus mu. So we're going to do that. So fill in that. So we have X, 59. Z 2 times, we don't know. That's what we're trying to find. Plus 45. We're going to solve for that. So what are we going to do? Well, remember back in your algebra class, we need to get rid of this so we can work it. So maybe we could subtract 45 from each side and subtract 45 from this side, which gives us a new equation of whatever 59 minus 45 is here equals 2 times sigma. So maybe we could divide both sides by 2. So that gives you an answer, but I'm not going to give you the answer. So hopefully this helped. If not, you can email me, obviously, and I will help you out with that. But sorry, this one was a little bit rough. I just wanted to use my notes so that I didn't get anything wrong, and then they confused me more. But we struggled through. We made it. And luckily, I don't have to watch this video and cringe. You do, and it's cringy to me that you have to watch it. But hopefully, if you needed a little bit of help and you needed to see where the numbers went and the formulas went, this helped you. And I would just make a cheat sheet of those formulas as we're going through. So now you have your formula to convert to a raw score and z-score and convert back to another raw score from the z-score and different standardized scores and all the things we talked about in the lecture and then in here. So I hope that helps. And email me if you need anything. Thanks, class.